Hello and welcome back to my YouTube channel. Before we start, don't forget to share, subscribe and like. So let's continue from where I stopped on my previous video. I told you that I will do for graph where we called modulus. So it's quite simple. What is a modulus? And before we do a modulus, the graph questions that I actually find out to do with you guys. There are a few questions to do. So first we're going to see the difference a function with a modulus and without a modulus. So here's a function. So here is a function which is not with a modulus. A function that don't have a modulus. You guys can see that. So how are you going to sketch a graph? So first thing to sketch a graph, as you already learned this in your lower form, how to sketch a graph, isn't it? So a very basic method is doing a table, isn't it? So same thing, to sketch a graph you have to do a table, isn't it? Remember, like how you do your x and y, do a table. And after that, do 4 rows, and the first and the last row you have to fill with the numbers that they give, the number of the domain. And in this question they give you domain, which is your x, is in between of -1 and 4. So you're gonna put -1 and 4. And what about the middle part? What are you going to put here and here? So as you learn this in your lower secondary, if there is no number, the most common number we use is 0. So put 0 in between. And now find the partner of it. So if your x is -1, what is your fx? That's what you have to find, right? So do substitution, which we learned yesterday. So when your x is -1, sub your x -1 equals -1 minus 3. So you're getting -4. Key in the -4. I use different color, yeah, so you can see. So what about when x is 0? So when the x is 0, sub your x 0 and also sub here 0. When your x -1, sub -1. When your x is 0, sub 0, because the equation substituting the x value there. So sub your x, and 0 minus 3 is -3, so key in -3. And now your x at the bottom is, your fx is 0. So this time around your x is not equal 0, but instead of your x 0, your fx is equals to 0. So now you're not supposed to find the fx, instead you already got it. What you have to find is the other side, which is the x. What you have to find is the x. You don't know this, the x, and that's what you have to find now. So what is your fx? I think we got it. There, this is your fx, x minus 3. So key in x minus 3, and this is equals to 0. Find your x. -3, bring that side, become +3. And you got your answer, your x is 3. So what's next? Find the fx. Now you got your x 4. So when your x is 4, what's your fx? So sub all your x 4. Remember, yeah, substituting so important. So your x 4, 4, 4, you sub, and now find the fx. 4 minus 3 is 1. I should just read back. So now you already fill up the table. If you see, the table is all completed. So now you have to do is sketching the graph. And I hope you know how to sketch a graph. So to sketch a graph, you need to have two axes. One is x, another one is fx. X-axis and y-axis. And then you have to label the maximum and the minimum number in the axis. So let's look at the x. Your maximum number is 4, the highest number. So put here 4. And the lowest number is -1. Put -1 here. What about for your fx? So your fx, your maximum is just 1, just somewhere around here. So looks like I have to adjust my graph. Okay, so wait. Let me adjust my graph. I think I should bring this up. Now it looks better. So the maximum is just 1, as you can see. And the lowest in your fx, see again, the maximum in your fx is 1. Okay, and the minimum is the negative for the lowest number. So that will be the last at here. And here will be 0, the origin. And now label with the other numbers. Your x, you have -1, 0, 3, 4. So -1, 0, 3 is somewhere roughly around here. Sketching, you don't have to be accurate. You just need to roughly measure. Okay? And after labeling your x, label your fx. So your fx, there is -4, which already labeled, 1 already labeled, 0 already labeled, now -3. So let's label -3 here. And now what you have to do is plotting. This is exactly the same what you learned in your lower secondary, I guess. So how you plot according to the coordinate. So how you read this table, follow the coordinate. So remember, your coordinate is always your x and your y-axis, isn't it? This is how you read the coordinate. So in this case, your x remain x, but your y, instead of y, you use fx. It's the same thing. Sometimes the question do give you y instead of fx, they do say y. It depends on the question. Sometimes they say y, sometimes they say fx. If they say y, you put y. If they say fx, you put fx. Most of the question they use fx, so use fx. If gx, gx, hx, hx follow the question, you just have to replace the y-axis according to what they give. The x-axis remains the same, don't have to worry. So now this is how you read a coordinate. So when your x is -1, your fx is -4, isn't it? So your coordinate you read like this. Your x followed by your fx. Same goes to this. 0, -3. 3, 0, 4, 1. Isn't it? This is the coordinate that you actually find out from the table. Now what you have to do, transfer all these coordinates into the graph just by plotting them. So guys, let's plot. So -1 and -4. So isn't it here? It's roughly around here. You are sketching, so you don't have to be accurate. 0, -3. So your x is 0, your y is -3. Isn't it somewhere here? And now Your x is 3, your fx is 0, isn't it, somewhere here? And your x is 4, your fx is 1, so somewhere here. So if you realize, it's actually you're getting a straight line. Maybe I should bring this on top. I hope roughly you should get about a straight line. Maybe my drawing is not too accurate, but if you see, wait, let me adjust my graph so it looks better. I don't have to worry because I have these editing tools, so no worries. Yeah, sketching you can't be exactly seen as too accurate because the scale is not accurate, so you might not get a straight graph. So you adjust, you have to adjust, but you have to see a straight line. So your graph will look like a straight line. But now, this is how you before I talk about the next part. This is how a graph that you sketch, you draw when you're in lower secondary. But what's the difference in Addmaths, and especially in this chapter, is when you have a modulus. So nothing so special in this, but now if I give you a modulus something like this, you have to see the equation that I provide for both is the same. Fx is equals to x minus 3. Fx is also equals to x minus 3. But what is the difference you're going to see here is the modulus, and what the modulus can make it different. Alright, so before I talk about the difference, you need to know what is modulus, right? So what is the modulus? A modulus is something that makes number positive. No matter what number inside, it will be a positive. It's always a positive answer you have to get. You cannot get a negative answer. For example, I have 5. I put 5 inside a modulus, so my account will be 5. This will be my answer. If I put modulus negative 5, it will be 5. You have to be a positive number. If I put negative 10, I will get 10. If I put 7, I still get 7. No matter what number you put, you have to get a positive number. That's the function of a modulus. Okay, that's what you need to know. But what if I put an unknown inside? Maybe x, modulus with x. What do you think my outcome? I don't know. The answer will remain as the modulus x. If I put modulus x plus 3, maybe not plus 3 lah, same example, x plus 10, the answer will remain with the modulus. If I put x minus 10, do you think it will change to x plus 10? Because as I said, modulus makes number positive. The answer is no. It will remain the negative. So one thing you have to know, the function of modulus is making a number positive, but at the same time, when there is an unknown inside the modulus, you realize the modulus will remain the same. It has no function. The modulus will not change anything. It will be the same. It will not change anything. So if there's an unknown, but what if there's a normal number? You will get the outcome. You will get the final answer directly. So take note, guys. when you have an unknown, you will get the same result, no change. But when you have a number, you put a number, you will get a positive outcome. Everything is positive. So, and this is about modulus. And now, how does this modulus affect a graph? So what I'm going to do now is I'm going to sketch the same type of graph but with a modulus, and you will see the difference. And before that, I want to put this aside. It's like so annoying. Okay, nice. So let's just sketch the same graph, guys, using the same values. So the domain is -1, x4. So let's do the same thing. So to sketch the graph, there's no any different way. It's the same thing, isn't it? As I say, you have to do a table. So the method of doing the graph, there's no change. So let's do table x fx, do 4 box 1 2, I mean 4 columns are okay, 2 3 and 4. I think it's too long. Let me just erase some. Okay, so it's from -1 until 4. So the remaining part, just put 0 and 0. So now let's do the same thing. Fill up the table, complete the table. So when x is -1, so what happens to your fx? Remember, don't forget your modulus. Your modulus. See, my fx. So what exactly inside the function equation, I put back the same thing. You see, I put the modulus back. Next, my x. Now I know my x is -1. So let me replace my x with -1. And I minus the 3. The minus 3. The minus 3 part is the same thing. So what I have to do now is just a simple mathematics solve. -1, I minus 3. So -1, I minus 3, I get -4. And guys, don't forget, I have a modulus inside. Remember? The modulus I maintain. I did not do anything. Now, is this our final answer? The answer is no. Because remember, I told you just now, when there is a number inside a modulus, is it a plus or a negative or any number, the outcome have to be a positive answer. So if I put a -7, my modulus inside, it will be a 7. If I put -10, it will be 10. If I put 10, it will also still be 10. No matter what, it will be 10. It will be the positive number. So same, if I put a -4, I will get 4. So this will be my final answer. I'm gonna key in 4 now. Okay. Now let's move on to the next one. So now your x is 0. So let's substitute when your x is 0. So when x is 0, your x is 0. Don't forget your modulus, and your x, you replace with 0 minus 3. So 0 minus 3 is -3. And -3 modulus, it will be +3. So far so good. I hope I'm not going too fast. So now, before I do this, I want to finish this one first. Let me finish all the bottom one. So now when x is -4, let me erase this thing, so annoying. So when x is 4, what happened to my fx? Don't forget the modulus, minus 3 minus 3. Your x is now 4, substitute 4. So 4 minus 3 is 1. So positive or negative number, your outcome always positive. So it remains the 1. So your 1 kekal as 1. It will remain. No change to the 1. Okay. Now let's go to this, guys. Fx is equals to 0. Now what's your fx? This entire thing, right? So let's go copy the entire thing, and this is equals to 0. So how are you going to solve your next step? Are you going to do like a normal mathematics, 0 plus 3 equals to 3, like that? How? Any idea? How are you going to move on for the next one? So you see, this way you cannot do this way because you have a modulus there. You should do something to the modulus. You should remove it. So how are you going to remove it? You're going to shift your modulus this side. It's something that impossible, because if you shift to that side and the modulus is going to maintain the modulus, there's no difference at all. So what you're going to do, you have to change it into plus minus. So I know you have to move to another part, but not moving the modulus. Instead of moving the modulus, you're going to move and become plus minus 0. Plus minus 0 means it can be positive 0 or negative 0. Why? Okay, if let's just say I have 2, what is the outcome? If modulus 2, it will be modulus, the answer will be 2, right? What if my modulus is negative 2? It's going to be 2, isn't it? Because as I say, the modulus function is to make number positive. So 2 or negative 2, when you have a modulus, it will be 2. So now if I say this 2 comes from which 2? Is it positive 2 or the negative 2? How you know? Isn't it? If you say positive 2, but you also know that when you have a negative 2, you put a modulus, it's going to give you the 2, isn't it? And if you say negative 2, if you put a modulus to the positive 2, you're still going to get a 2. So both answer also can be acceptable. So the chances to be a positive 2 or a negative 2 is there. So that's why we bring a concept when there's a modulus. When we shift it this side, it becomes plus minus 2. Now if I say this modulus 2, if I shift it this side, it can be a plus minus 2, because the possibilities to be a positive number and it can be a negative number are there. So we can't just assume that one of these answers is only correct. You're doing Addmaths, so we have to be specific. It can be many answers. You will do more chapters, you will see a lot of different types of answers, and it can be more than one at some time. So you have to be familiar with that. That's the reason why when you shift the modulus, you get a plus minus. It's something similar, a concept for this. If you have 2 square, it can be 4, right? Negative 2 square is also 4, isn't it? So now this 4 comes from this square or this square. It can be both, right? So we can say plus minus. That's how we will do. Same for the modulus also. You get the idea? I hope you guys get it. If not clear, watch again or watch other people's YouTube video and then get back to this. You might understand. But this hopes helps your understanding. So that's how you should move your modulus. Make it plus minus. It's always the same. So now your 0 is plus minus 0, but in this case it's like a bonus. Guys, you know 0 is positive or negative. It's neither positive nor negative. It's in middle between the positive and negative number. So 0, it's none of them. So for 0 only special case, you just can ignore and maintain x minus 3. Yes, but if let's just say I say my fx here is 4, let's just say, and then it will be plus minus 4. So if that is the case, you have to separate it, but in this case it's 0, so you don't have to do anything. You just can ignore the plus minus. Later we will do a question something got modulus, and then I will explain you a little bit more. Okay, now just ignore the plus minus. For 0 you don't have to worry, but for other than 0 you need to worry. Okay, you have to do a 2-step, more than one, 2 steps. So and then your 0 minus 3 move this side become positive 3. So in this case your x is equals to 3. So done, you have already completed your table. So let's sketch the graph. So I hope you're clear with the modulus. So it's the same thing, guys. It's just like your square root, you bring that side become plus minus, right? It's the same thing. So now let's sketch the graph. So sketching graph is no difference at all. So fx, label the axis, and then do the range -1, 4. Guys, don't forget the range. Your table follows your range. The range usually exam will give you. The question 99.999% the question will give you the range if you want to sketch the graph. Okay, you have to follow the range. -1, 4, -1, 4. You have to follow that. And then for your fx is 1 and 4, so 4 maximum to 1 is the minimum. And then label 0, 3. 3 is somewhere here, 3 is somewhere here. And what you have to do now is the same thing, right? Coordinates. So let's go coordinates. It's x followed by your y-axis, which is your fx. So same for the 0, 3, 3, 0, 4, 1. Your x first, and then only your fx, your x, y. Your coordinate follows this pattern, right? Oh shit, ugly. X, Y, something like this, right? Same thing. So now let's plot. Plotting shouldn't be a problem. In sketching graph, you don't have to be too accurate. So -1 and 4, so it's somewhere around here, isn't it? If you're not too sure, you can draw a dotted line, and then 0, 3. When your x is 0, your fx is 3 is here, and then 3, 0, it's here, and then your x is 4, your fx is 1, so it's somewhere here. Roughly draw lah. Sketching, you don't have to be too accurate because the scale is not too accurate, so you might not get a graph. So what you will see is something different. You will realize you will not get a straight line like this, but instead not nice. Yeah, this is the oldest problem even I made because of the scale problem. Now it looks better. So what is the difference? You didn't get a straight line, isn't it? This is because of the modulus. This is what modulus do in a graph. Remember guys, when there's a modulus in a function, 99.9999%, when you do a graph with a modulus, you will get a V shape or a tick. This type of shape or a V shape, either one. You will never get a straight line. Why is it? Because as I say, what is the function of modulus? Makes number positive. So you see the difference. As you see the line at the above, you know the basics of graph. Here is all positive. When you go below, it's all negative numbers. What is the function of the modulus? Makes negative number to positive, right? So that is what happens here. It makes number to positive, right? So it will reflect it. This part, instead of going down, it goes up. It reflects, and that's what you see here. It reflected above because that's the function of modulus. It makes number positive. Okay, it's too ugly to see this type of drawing. Let me draw a dot so nice to see. Looks better. So clear about this, what the modulus make? So that's why you get a V shape or a thick shape, a right, the right or a thick shape. So clear about modulus? Hope there's no problem, and I hope I'm not too fast. So I think that's all for the first part of your function. We are done. So before I move on to composite function, which I think I will do on my next video, so what I'm going to do after this is doing exam type of questions that you will see. So let's do this example with a modulus. Before I move on to the exam question, which I forgot that there's another example. My bad. So let's do this, guys, before we move on to exam questions. So as I say, a modulus question with a graph. First thing, no matter what, do table. So let's do table. X, fx, do with a 4 column, 1, 2, 3, and last 4. So you have negative 2, 2. Always start from the domain. This one they will give you an exam, don't worry. Negative 2, negative 2, and positive 2 put at the corner. Since the x put it corner, you also put it corner. And the remaining box, up 1 0, down 1 0. Now let's do substitution. Let's fill up the table. So let's do, when your x is negative 2, what happened to your fx? So this is your function that they give you, right? So yeah, that's the same thing. Let's do modulus. Don't do anything. Substitute your x, replace it with negative 2 and minus 1, okay? And then solve it. Negative 2 square is 4. 4 minus 1 is 3. So modulus 3, positive number maintain positive. It will be 3. Settle. Now next one, x is 0. So when your x is 0, your fx is 0, modulus, and substitute your x with 0, minus 1. So 0 square is 0. So 0 minus 1, you press your calculator. If you're not sure with your answer, you will get a negative 1. And modulus makes the negative number positive, so you will get 1. So instead of negative 1, you will say 1. And next, let's fill up the x first. So when your x is 2, do the same thing, guys. It's just the same thing. Modulus, maintain, and your x is now 2 square minus 1. So 4 minus 1 is 3, right? So modulus with 3 is 3. So there's no difference here. And now let's go to the fx. This time around, we are not finding your fx, we are finding the x, this. So, but they give us fx is equals to 0. And what's your fx? That it's right here in front of you. They already say clearly x square minus 1. And this is your fx. And they said this is equals to 0. So let's just make it equals to 0. And the modulus, remember, bring that side, become plus minus 0. So but for a 0, it's a special case, you just can ignore them, because 0 it's not positive or negative, they are at the middle, so you don't consider positive negative here. So what you have to do, the minus 1 bring here, and your square root. Not nice. Your square bring here becomes square root, isn't it? 1. So what is square root 1? You press your calculator, you can get 1. But remember, guys, when you bring your square root, you're not just bringing that, you also have plus minus here. Okay? It's the same concept. If let's just say I have 2 square, the answer is 4. Negative 2 square, it is also 4, right? So if this 4, I ask you, is this come from this 2 square or negative 2 square? From which? It can be from the both, right? So when you want to find that, you have to do plus minus square root of 4. So when you do that, what's square root of 4? It's 2. So it will be either 2 or negative 2. So there are two answers, same for this. So you get plus minus 1, which means your x will be 1 or -1. It can be both. Yes, the special case for this. It can be both also. So your coordinate here, instead of 1, you have 2. So it will be 1 and -1. Put a comma there. And let me erase this. It's so annoying. I mean, not annoying, it's like ugly. I don't like make my notes to be ugly. So next thing, do coordinates, isn't it? So it will be -2, 3. Remember your x first, followed by fx, 0, 1, 1, 0. And not only that, you have -1. So do it -1, 0. So this time got 2, one this, another more this. I use 2 highlighters. There is 2 extra, so do it 2. Okay, and 2, 3. And you got your coordinates. Let's do graph. Let's do this graph. Yeah. Ooh. Let me adjust according to the question. -2, 2, that means it's at the middle. And bring this up a bit, make it nicer. Does it look nice? I hope so. And this is fx, right? Fx. And now let's label the coordinates, the scales. -2, 2, and there is -1, 1. Isn't it? There is both x, 2x values. And then for fx, there is 0, 1, and 3. So 1 and 3 is put it on top. Now let's label the coordinate. So you have -2 and 3, so which is here. Roughly plot it. As long you plot correctly, you can ready. Next, your x is 0, your fx is 1, which is here. Next, 1, 0, your x is 1, your fx is 0. Next, your x is -1, your fx is 0. Your x -1, fx is 0. And then 2 and 3. 2 and 3. It's this. 2 here, 3 here. So what type of graph you will get here? You have two possibilities. One, you can get this graph. Oh my god. So sorry, maybe my scale is not accurate enough. Yeah, that's okay. Let me adjust. Another possibility is you will get this graph. Sounds like my graph is not so nice. Not nice. I should make it nicer. Okay, hope this works. So these are the two possible graphs. Both also give you V shape. So at this point, you actually can make a conclusion which one you have to choose. But if you have two possible graphs, we will take the middle one. Yes, usually if there's two graphs, when you have one and negative one, where you don't see a perfect V shape, where you have like one something so weird number, something so weird coordinate, we will make the middle of them. So you have to plus the both and you will divide by 2. So in this case, you will get a 0, which is somewhere at the middle. Yeah. In this case, you'll get somewhere at the middle because this is how your graph will look. If there is a 2 outcome and you don't get a perfect V shape, because if let's just say you draw this graph, you will have one something like a weird outcome here, isn't it? But if let's just say you draw this graph, and this will be the weird outcome, weird coordinate that you will see, isn't it? So to avoid this, you will take the middle one. You will take the plus the both and we will take the middle one. And that is possible, but at the same time, if you take the middle one, you will have this one a weird one. It will be like this. If I take the middle one, it will be 0, right? And then this one will be like a weird. You don't get touched to that coordinate. So I think for this case, you will choose one of it. You don't choose both. You have to choose one. You have to make a conclusion. You can ignore this one. Maybe. You can choose either one. For this case, yeah. So you can choose this. You can also choose that one. So let me draw two possible graphs that you will see. Yes, you can, because in this case, to avoid from all this one a weird coordinate that did not touch in the straight line or to the V-shaped line, we can sacrifice one coordinate, one plotting point, so you will get a perfect line. But it's very weird to see this type of question. I purposely took this type of question so that you will have a you can be familiar to this random type of question. But to be honest, this is not. Oh wait, my graph is not nice. It looks better. So you have two graphs, either one you draw. You don't have to draw both. Wait, this is not a perfect graph. It did not touch the one. It should touch the one. It's not straight, but guys, something like this. Wait, let me make it better if I can. This one did not touch at all. how I should adjust this. I need to make it touch this one, and I couldn't. You know what, guys? Actually, this part should be 1 because I can't adjust the graph, assume it 1. Okay, so you have two possible graph. It's two random type of question. In SPM also they haven't asked yet, and I purposely give this question so that you actually can encounter and get familiar with different type of question. Okay, so these are the possible graph and possible questions for graph sketching. And you also see from here, when there's a modulus, you have a V-shaped graph. No matter what, you always see a V-shaped graph, isn't it? You will see a V-shaped graph because, or else it will be a linear graph. If there's no modulus, it will be a linear, it will be a straight line. But because of modulus, it reflected to the positive side, so it will be a V or thick, a right shape. And from here we are done. So this is a random question, so you will encounter a different type, a bit different. Yeah, it's very different, it's very random type of question. They don't answer you. I only saw this question in trial paper 2024. There's one state they asked this question, so I took it from there. If you do a trial 2024 paper, and then you might see this. So there's two possible. So now let's go to exam type of question. Some of the question I took it from trial paper, some is just for understanding. Okay, I took it from my revision material. So this is all you need to know for a function. So now to make sure everything you understand function, let's do a few exam type of questions. Okay, so I think there are quite a lot. I think not a lot lah, just 4. Yeah, it's just 4. And from this we are done with function. Okay, given a function something, a equation, and they say x is not equals to m. Where is your x? Here. And this is not equals to m. Find the value of m. So how are you going to find? You should know one thing. In a function, let's just say fx and something, whatever lah, let's just say on top whatever number, and at the bottom, remember, it cannot be equals to 0. On top it can be any number, it can be 1, 10, let's just say 1 lah, too lazy, just 1. But at the bottom it can be any number except 0. It cannot be 0. Your denominator, when there's a function, you see, if there's a fraction, automatically in your mind you have to remember one thing: the denominator cannot be equals to 0. That's the thing that you have to know. So at this case, you're on top 6. It can be any number, I don't care. But your bottom denominator cannot be equals to 0. Remember this, guys. It's a very common exam type of question. So from here, you actually can do to find what is your m. So what you have to do, move your x one side, move normal numbers one side. So 2x you move it here, and 1 you maintain here, and then your x is 1/2, and then you shift this side, so you get a fraction. And now you see the pattern that they give you. X is not equals to m, and what do you find? X is not equals to 1/2. Compare both of them. X is not equals to 1/2, and compare the question give you. So your x, same, not equal, same. That means your m have to be same as 1/2 lor, isn't it? So your m is equals to 1/2. That's it. Isn't this so easy? So I hope you guys can do this. Remember, your function, your fraction at the bottom denominator cannot be equals to 0. It's a condition. The reason why, because when your fraction, your denominator is equals to 0, if you press your calculator, let's just say 5/0, what do you get? Math error. 1000/0, math error. So you realize whatever you press your denominator equals to 0, you will get a math error if you press in your calculator. So that's the reason why your function, your denominator cannot be equals to 0. Because if it's math error, then how are you going to solve your problems if your denominator is equals to 0, isn't it? That's the reason why you cannot be 0. Your denominator cannot be 0, or else it will be math error. You cannot solve a function. So let's go to the second question. Find the value of k such that fk equals to negative k. Don't worry, you don't know what's the k, they didn't give you. It's okay. Let's start from the information they give us. They say fk equals to negative k, right? Oh shit. So let's start from there. Fk equals negative k. So start from here. Now this is fk. So what is fx? They give us fx 6/1 minus 2x, isn't it? But now my x is no more x. My x, they actually replace it with k, isn't it? So we also replace it with k lah. So 6 minus over 1 minus 2. So my x is no longer x. So instead of x, it's k. Isn't it? This is my fk. So that's what I'm going to write here. You see, I didn't change anything. I'm just writing the same thing, but in a different way what the question tell me. From what the question tell me, I just write in different way. Because as you know, if let's just say my f here is 5, that means 6/1 minus 2 times 5. Isn't it? This is how I will write, right? If f10, it will be 6/1 minus 2 times 10. So it's the same thing. If my f is k, I have to write 6/1 minus 2 times with k. I didn't change anything. If my x, then I just write x lah. 6/1 minus 2 x. Just follow what they give us. You don't have to create on your own. So from what they give, I change based on what they give me. And then I didn't do anything, the negative k, I maintain the negative k. So now just do your normal mathematics. It's 6 over 1 minus 2k negative k, and now this bottom, bring this side, it will be times 1 minus 2k times with negative k. Actually I should bring this entire thing. So let's continue. So what you have to do is expand the bracket, times here, so negative k times 1 negative k times negative 2k is positive 2k square, and then bring the 6 to this side, so you get a quadratic. So positive 6, bring this side, become negative 6, don't forget that. And now it's a quadratic, so quadratic, press your calculator. So if you press more equation degree, and you press your key in your A, your B, and your C, you get answer equals 2 and negative 3 over 2. This is the answer. If you key in your calculator, factorize them in calculator, you get 2 and negative 3 over 2. So this is what you get for your k. So one, your k is equals to 2, another more k equals to negative 3 over 2. So that's the thing you have to write, but in a bracket you have to reverse it, so you do reverse engineering. So k here, the 2 you bring inside become minus 2, because positive 2 become minus 2, so that's what you have to write here, k minus 2. And same for this, so this one bring here as 2k minus 3, and then minus 3 bring here plus 3, so write here 2k plus 3, and you get k equals to 2 and negative 3 over 2. You just do reverse engineering. I think this you should learn this in modern maths if I'm not wrong. Just press your calculator, you don't have to worry. If the black color calculator, you press mode 3 times, you press mode 3 times, and then press equation, which is 1, the number 1, and then unknowns. And if you don't have to press the unknown, you press the left side button, and then you will see a degree there. So the degree, they ask 2 or 3, you press 2, because it's the quadratic one is 2, cubic is 3. So press 2 and you key in your A. They ask A, B, and C, and you key in each of them, you will get the answer already. So this is how you press in the calculator. So done, you find the value of k. That's it. Next question. Given mx, so this time they say mx, so as I say, your function is not always fx, it can be hx, mx, gx, cx, dx, it can be a lot. It doesn't always have to be fixed with fx, okay? It varies depending on the question, how they want to give. So now mx, let's go. They give us mx. And they say x cannot be equals to 3, which is true, because if your x here equals to 3, so imagine 3 minus 3, you get 0. Isn't it will be a math error if your denominator equals to 0? That's the reason why it cannot be equals to 0. Okay? And they say a value of x maps to itself. I think I do teach you yesterday about this, my previous video. I explained about this. Map to itself. When maps to itself automatically, you have to remember your object is always equals to image. That means your x will be equals to fx. You will get the same outcome. It will be the same. It's like this. Let's just say this is my x, this is my fx. So if here is 1, here is 1. Here is 2, here is 2, here is 3, here is 3. You will get the same answer. So that's why when your x is 1, so if you put inside f1, you'll get 1. If your f is 2, you put 2, right? You'll get back the 2. If your f is 3, it's 3. You'll get back the same. That's why when your x, instead of x, you get back the x. So the same thing. This time, you're not using fx, you're using mx. So mx, you will get back the x. Get the idea? I hope you guys get the idea. I just put it here. So from here, you can actually find out. So what is your mx? This is your mx, and they already gave us this. So instead of writing this mx, I'm going to substitute this over here, because they say mx is equals to this so I just substitute the same thing 3x minus 5 over x minus 3, and this entire thing is equals to x. You see, again, I'm not changing anything. I'm writing the same thing but just a different way. That's it. So now let's do your normal mathematics. Your fraction denominator, bring that side, become times your x, bring here x minus 3, and what you have to do is expand this. X times x, x squared, 3 times x, 3x, and 3x minus 5, and then bring everything to one side, make equals to 0, because if you see a quadratic, then you have to make it equals to 0. So x squared minus 3x, and then 3x, bring this side, become minus 3x. Here's positive, bring here negative, and negative 5, bring here positive 5, and equals to 0. So minus 3x, you will get minus 6x plus 5. And now you have to key in inside the calculator. And you'll get x equals to, wait, let me key in the calculator. 1, negative 6, 5. So you get x equals to 5 and 1. So you can actually make it x minus 5, x minus 1. And there you go. I find the value of my x. It can be more than 1. Remember I told you just now? That's the thing. So we're done with this question. Let's move on to next. Now kx. And this time, I think this is a trial question. I take this from trial paper, but I forgot which state, guys. I'm so sorry. From 2023 SPM trial paper. The modulus graph one was 2024 trial paper. This is 2023, but I just forgot which state. My bad. So they say kx is equals to ax plus b. And they say they give us a few information. When your k is 3 equals to 2. And they also say k1 is equals to negative 5. Find the value of a and b. What is my a? What is my b? I should find it out. And how? Let's do it one by one. So it's so easy. Remember, whatever inside your bracket, it's always your x, isn't it? Not nice. And whatever outside is the kx, which is the image. So you need to remember whatever inside the x bracket is the x, right? So now in this case we use the first clue which they give us, k3 equals to 2. What is inside the bracket is 3. So now let's replace your x to the 3, because instead of they writing that x, they write 3, so we just write 3 now. We substitute your x to 3. So your a, I don't know, I write the same thing. Your x, I know, is 3, so I write 3. And my b is b, which I don't know, and this is equals to 2. I didn't change anything, I just write the same thing but in a different way. Okay, so far clear? So a times 3 is what? 3a. I plus b equals to 2. So I can, this is my first info, I get it. So let's do the second one, the second info. Same thing, whatever inside my bracket, it's always telling the x. So same thing, I change it, the x all to the 1. So k1 equals to -5. And what is my kx? My a is my a, I don't know, and my x is 1 this time here. So I replace it with 1. This one 3, I replace it with 3. And I plus b, which I don't know. And this is equals to -5. And 1 times a is a lah. Whatever times 1, you get back the same thing, right? And a plus b is -5. It's the same thing, I didn't change anything, I bring it down. And you see I have 2 equations, equation 1 and equation 2. It's just your basic mathematics after this. It's your normal maths which you learn in lower secondary. You have 2 unknowns, 2 equations. What do? Simultaneous equation. So let's do simultaneous equation. You have 3a plus b equals to 2 and a plus b equals to -5. So in this case you can use elimination method or substitution method. So for me, I would prefer to do elimination method. So I will take equation 1, I minus the equation 2. It's easier compared to substituting. So I take 3a plus b, which is equals to 2. I minus with a plus b equals -5. So 3a, I minus a, I get 2a. b minus b, I cut. b minus b is 0. Let me write my a nicer. And 2, I minus -5. 2 minus -5, which is, you press your calculator, you should get 7. So my 2a is equals to 7. My a is 7/2. And I find it. Your 2 bring this side, become divide, so 7/2. And now I should find my b. I find my a already. Ta-da! And now let's find the b. How? Substitute inside any of the equation, maybe equation 1 or equation 2. For me, I'll prefer equation 2 because the numbers are too easy. So I say sub a 7/2 into my equation 2. A plus b is -5. But now my a is 7/2, right? So sub 7/2. And what is my b? So -5. The 7/2 bring this side, shift this side, become -7/2. And if you press your calculator, -5 minus 7/2, you get -17/2. And then I got my a, 7/2 and might be negative 17/2. Ta-da! Here you go. Which what the question asks us, I find the both of them. Now let's go to the last question. Is this the last one? Yeah, this is the last one. Okay. They say gx is equals to 5 over x plus mx. And they say x cannot be equals to 0, which is true. Again, as I say, your denominator cannot be equals to 0. If it's equals to 0, you get math error, so it cannot be equals to 0. And they say find the value of m, which is this, which we don't know. And they say g bracket to the 5 equals to 16. They give us a clue there. Remember I told you, whatever inside your bracket, it's always telling you the x. So gx, isn't it? So your gx now, the x there, you replace with 5. Let's go. So what's your gx? This lah, but now your x is now 5, right? So replace everything with 5. All your x, every x. So this wait, this is, I use different color. This. So now your x is 5. So replace all your x with 5, 5, this thing, everything with 5. Plus m, and your x is 5. So this is what is g5, isn't it? So now I'm going to write this thing over here. Isn't it the same thing? So I'm just writing the same thing in a different way, and this is equals to 16. It's the same thing, there's no difference. I'm just writing in a different way. So 5 over 5 is 1, and m times with 5 is 5m. This is equals to 16. Do your normal mathematics after this. 1, bring this side. So 16 minus 1 is 15. So my m is 15 divided by 5, which is 3. Ta-da! I find my m. So I'm done with this chapter 1.1 actually. And I think my next video, I think I'll be posting for 1.2 composite function. So if you like my teaching way, don't forget to like, share and subscribe, guys. And see you in next video.